All right, so let's take a look at our word problems. Number 7 says Ren and Jenny are reading the same book. Ren is on page 14 and reads 2 pages every night. Jenny is on page 6 and reads 3 pages every night. After how many nights will they have read the same number of pages, and how many pages will that be? So we're currently solving systems of equations by graphing. So we technically have 2 equations here. The first situation, the first equation deals with Ren. And if she's starting on page 14, that's her y-intercept. That's our starting amount. And she reads 2 pages every night, or 2 pages per night. That means 2 is our rate of change, or our slope. So we have a y equals mx plus b equation here, which would be y equals 2x plus 14. Now we have Jenny. So Jenny's situation is she's on page 6 currently, so that's her starting position. And she reads 3 pages per night, so that would be our slope. So her slope-intercept formula, or equation, is y equals 3x plus 6. So there we have our system of equations. So we want to figure out after how many nights will they have read the same number of pages. So where do those 2 lines intersect? So we're going to start off first by labeling our coordinate plane over here on the right-hand side. So x, what is x? Well, what is m? What is our slope multiplying by? Well, it's 2 pages per night. So x is number of nights. So let's write our little let statement. Okay, so the x-axis is number of nights. And our y value, or the total from plugging in with this slope-intercept form, that's going to be our page number. Okay, so number of pages. So y is number of pages. And the overall situation is, I don't know, Ren and Jenny's reading. Mm-hmm. Doesn't always have to be pretty, but we just need an x and y axis label and a title for the overall situation. So if we start by graphing Ren, and unfortunately based on this real life situation, graphing isn't going to be the best way to solve this, but that's the only way we know how to solve right now with a system. So with Ren, her equation is y equals 2x plus 14. So her slope is 2, or 2 over 1. So rise and run. And her y-intercept, her b, is 14. Now, why is this not great to graph? Well, due to the fact that this is a real-life situation, if you look at your x and y axes, your x-axis is counting by 1s. Your y-axis is counting by 5s. So when I'm rising by 2, I don't literally count 2 full boxes. Okay, so let's kind of go through that. So if our y-intercept is 14, first of all, 14 isn't even exactly on here. We'll put it right there. And we rise 2 and then run 1. So if I'm rising 2 from 14, that's going to put me at 16. And then I'm running 1. So I'm going to be about 16, run 1. And then I'm going to rise 2 more. So then I'm going to be about 18. I'm going to be at 18, but I have to ballpark it, and run 1. And then rise 2 more, which is going to put me at 20, and then run 1. Then I'm going to be at 22, run 1. 24, run 1. 26, run 1. 28, run 1. 30, run 1. Okay, so it's not exactly perfect, but the 2 perfect ones, okay, were 3:20 and 8:30. So those were perfect points. So we're going to draw our line that's going to try to go directly through those. So there's Ren. And I don't like that line. It's way too thick. So I'm just going to label that as Ren. Now we need Jenny. So Jenny's situation is her slope is 3/1. Rise over run. And the y-intercept is 6. So again, we're going to have to ballpark. So y-intercept of 6 is going to be just above the 5 here. And we're going to rise 3 and then run 1. So the running is easy because each x is 1 unit, but the rising is more difficult. So 6 add 3 gives us 9, run 1. 9 rise 3 gives me 12, run 1. 12 rise 3, we're at 15, run 1. 15 rise 3, we're at 18, run 1. 18 rise 3, we're at 21, run 1. 21 rise 3, we're at 24, run 1. 24 rise 3, we're at 27, run 1. Ooh, we're getting close. 27 rise 3, we're at 30, run 1. Ooh, there we go. And then 30 rise 3, we're at 33, run 1. Okay, so we had to be pretty diligent and, again, not the best way due to the fact that the y-axis is not counting by ones. So this is Jenny. But as long as we're diligent, where did they cross? Well, they crossed at x was 8, y is 30. And especially in a situation like this, this is where checking our work is really important. So let's check 8:30 in Ren. So 30 is y, so 30 equals 2 times 8, which is, or 2 times x, which is 8, plus 14. That gives us 30 equals 16 plus 14, so 30 equals 30. So it worked for Ren. Let's check Jenny's. 8 and 30. So y is 30 equals 3 times x, which is 8, plus 6. Well, 30 equals 24 plus 6. So, yep, 30 equals 30. So even though it wasn't the prettiest approach, it did work because we took our time and we made sure we counted on those y's. Okay, so we had our solution of 8:30, but we need to actually answer the question that's asked. So after how many nights will they have read the same number of pages, and how many pages will that be? Well, that's where our x and y axes labels also comes into play. X is number of nights, and y is number of pages. So to fully answer the question, it would be after 8 nights, they will both have read 30 pages. Now, if you're panicking about this rise and run with these different scales, do not worry, because we will be solving these systems using easier approaches as we get deeper into Chapter 5, learning other methods. So we do have one more problem, another word problem here. And that word problem says that number 8, a Video Club A, charges $10 for membership and $3 per movie rental. Video Club B, come on. Video Club B charges $15 for membership and $2 per movie rental. For how many movie rentals will the cost be the same at both video clubs, and what is that cost? So we've got our two different scenarios. Video Club A is $10 for the membership and then $3 per rental. So 3 is our slope and our upfront cost is 10. So Club A's equation in slope-intercept form is y equals 3x plus 10. Video Club B is $15 for membership, so the upfront cost is 15, and its slope, M, is $2 per movie rental. So y equals 2x plus 15. And it's $2 per movie rental, so the slope is multiplying by number of movies, which is our x. So let x equal number of movies. So we'll put that on our x-axis. And the y value talks about our total cost in dollars. And we'll just title this Video Clubs. And we'll put cost. All right, so let's go ahead and start with Video Club A, and this is going to be similar to the last one because it's unreasonable for some word problems to just count by 1 on each axis. So you'll notice on the x-axis we're counting by 1s, but on the y-axis we're counting by 3s. So Video Club A has a slope of 3, or 3 over 1, and a y-intercept of 10. So we're going to have to ballpark 10, and then we're going to rise 3, run 1. So if I ballpark 10 on the y, it's going to be just past the 9. If I'm rising 3, I'm going to be now up to, what did I say? I start at 10. I'm going to be up to 13 and run 1. Add 3, I'm up to 16, add 1. Add 3, I'm up to 19, add 1. Add 3, I'm up to 22, add 1, run 1. Add 3, I'm up to 25, run 1. Add 3, I'm up to 28, run 1. So that one wasn't too bad because our rise was 3 and our run was 1, so we ended up kind of in the same relative position every time as we did our rise. All right, so there is Video Club A. And now let's check out B. So our slope for B is going to be 2 over 1. And our y-intercept is 15. So when we begin with the B, we're going to go to 15. So we've got a nice starting position there. And now we're going to rise 2, run 1. And again, on the x-axis, we're counting by 3, so we've got to just be careful. So if I rise 2 from 15, I'm at 17, run 1. So we're ballparking. Rise 2 from 17, we're at 19, run 1. Now we're at 21, run 1. 23, run 1. 25, run 1. Ooh, that looks pretty good. 27, run 1. 29, run 1. Okay, so I'm thinking that right here, at our 25, that's where we're crossing. And again, that's why the plug and chug to verify is super duper important. So that's our line B. All right, so we think that x of 5, y of 25 is the solution here. So let's check that out. So let's check A. So y equals 3x plus 10, so 25 equals 3 times 5 plus 10. So 25 equals 15 plus 10. So yeah, 25 equals 25. For club B, y equals 2x plus 15, so y, 25, equals 2 times x of 5 plus 15. Does that work? Looks like it. 25 equals 10 plus 15. So yes, 25 equals 25. So our diligence here did pay off. So our ordered pair 525 is where they intersect, okay? Which means, again, if we use our axes labels, X represents movies and Y represents the cost. So answering the question, for how many movie rentals will the cost be the same at both video clubs and what is the cost? Well, it's 5 movies at a cost of $25. So the cost will be the same for 5 rentals, and that cost is $25. Okay, and again, if you're panicking, this will get slightly easier with more algebraic, arithmetic type approaches as opposed to graphs.